For problem 46, we're looking for the limit as x approaches infinity of this rational function. So again, the trick is to divide by the highest power, so we'll divide by x to the third, and that's not an issue here because x is not going to be 0, x is going to be some positive value. So what we're going to do is we're going to replace this function right here with the following. And now this, the limit, these two guys right here, this limit and this limit as x goes to infinity, these guys are going to drop out, right? Because as the bottom becomes bigger and the top stays the same, this is going to go towards 0. So we would write it like this: the limit as x approaches infinity of 1 plus the limits as x approaches infinity of 2 over x to the third over the limits as x approaches infinity of 3 plus the limit as x approaches infinity of 1 over x squared. And so this guy right here goes to 1 because the limit of a constant, regardless of what number we're approaching, whether it be infinity or not, that's going to be equal to that constant. So this would be equal to 1 plus, now the limit of this guy is 0. And think about that. If this grows really large, you have 2 over a huge number, and if you take 2 and you divide it amongst a lot of things or a lot of people, however you want to think about that, that's going to go to 0, right? I like to think about it like money. If I have $2 and I want to divide that amongst a lot of people, each person gets very little. In fact, as the number of people increase, the amount that each person gets goes towards 0. And so again, we get 3 here because this is a constant, and we get 0 here. So this gives us 1/3. Now you need to walk me through these steps right here. You can't just go from here and say, well, this is equal to 1/3 and I'm done. We need to see the logic from here over to here to here. Now another thing that you could do is you can look at the graph to verify this. So what I'm going to do is I'm going to pull up Desmos. I'm just going to show you. Let me get you to Desmos here. Now I know you won't be able to see the full screen here because I've got it pieced in. But so let's go ahead and take that function. We were looking at the following: x to the third. Sorry, I gotta find it here. Plus 2, and we want to divide that by 3x to the third plus x. Now the question is what happens as we go out towards infinity. So as x, if we follow this along, as x goes in this direction, what's the height value of the function? And notice that as we keep going, it's between 0 and 1. In fact, if we keep going out forever, this will be at a height of 1/3. Now it's not as easy to see, but you can tell. Do you see how these height values here are getting the y values? They're 0.3. Do you see that? Okay. So that's another way to go ahead and verify, is just check it on a graph and say, okay, well, what happens as we come up this direction? What are our height values of our function reaching? Notice that up here, the height value is 1.259. They get smaller and smaller, and it doesn't take them very long to hit that 0.3 repeating. Okay. Now, of course, I never actually get there. That's just an issue with the rounding of the graph, but that's what we're approaching.